Loya Newton.
Tala ndenge force epusaka bloko yango wana ezotambola.
Force ezali makasi oyo epusaka biloko.
Resources Hub, and our mission is clear: to democratize world-class STEM education for Africa, starting small, proving impact, and scaling responsibly. We believe the next Asian is African, but today too much potential is lost, not from lack of talent, but from lack of access. Our project exists to change that story. Let's start with the numbers. Over 60% of African youth aged 15-17 are out of school. Of those who remains, only 9% reach higher education. By 2030, Africa will need 23 million additional STEM graduates just to meet basic needs. The problem is systemic, built on 4 barriers: infrastructure gaps. Most schools lack electricity and laboratories. Linguistic and cultural disconnect. Most STEM content is English or French, creating barriers for millions. Teacher shortage. Few teachers are qualified to teach STEM practically. Gender inequality. Women make up less than 30% of STEM students.
In sub-Saharan Africa, over 2,000 languages are spoken, yet all STEM research exists only in English and French. As a result, almost 70 of 10-year-olds cannot read and understand a simple text, according to research made by UNESCO. Without access to explanation adapted to local languages and realities, students are focused, especially who are focused on scientific concepts, appear inaccessible. The STEM Resource Hub is an AI-powered education platform. It translates, adapts, and generates contextualized STEM content in local languages using relevant African examples. We apply optimized deep learning models combining with an ethical Africa on data preparing to create learning that really speak to young people. Our AI model follows 3 key orientations, such as accessibility, which is focused on model that can learn on mobile devices and offline, and the equity, which focus on integration of local data to reduce bias and reliance of waste resource. There are also explainability, which focus on AI, which focus on the tool, which allow to understandable both teacher and learners.
Here's our flow diagram. Here's how it works. John starts confused in his physics class. At home, he opens our app and simply says, Loya Newton. The app instantly finds the lesson and plays it in Lingala. He listens and watches a simple animation while learning the concept. Next, he opens our 3D virtual lab. He drags mass and force, sliders, and sees acceleration happen. When he gets a quiz question right, the app saves its progress locally, even without internet. Later that night, when his phone detects Wi-Fi, it quickly syncs sending his results to his teacher's dashboard and downloading new lessons for the next day. It's fully offline, first, audio first, and built for Africa's reality, where connectivity is low but curiosity is high. Feasible. Our first phase is a focused strength math MVP, an adaptive learning engine, and lightweight 2D virtual labs in one subject, physics. We are not building expensive VR headsets. We are using open source web simulations that run on any smartphone, even offline. AI play a precise role, translating SAM's concepts and adapting lessons using local languages and analogies. Through partnership with Masakan and Labore AI, we ensure this technology is both African built and cultural grounded. This phase is not about scaling yet, it's about building something solid, current, and ready to. Why existing solutions will fail to close the gap? There are several players in Africa's edtech space, like School Lab in DRC, Colibri for offline content, and Flap for You for virtual labs. But each solves only part of the problem. School Lab focus on content management for schools, not interactive science. Colibri is an offline library but lacks labs and AI contextualization. Lab for You brings virtual labs but requires internet and doesn't adapt to local reality. STEM resources help is different. It integrates all four pillars: offline first access, lightweight 2D labs, AI that teaches using African analogies, and teachers focused analytics. It's not just another app, it's an holistic system built for African classrooms and beyond read.
Here you can see how our MVP is structured. It's designed as a hybrid offline first architecture to make sure students and teachers can use it anyway, even without constant internet. On the left, we start with the client, a mobile app, which works offline running the adaptive learning engine directly on the device. This allows students to access lessons, track progress, and run lightweight 2D simulation for physics and chemistry. A teacher dashboard in the browser, which provide monitoring, adaptive insights, and lesson bundles that can be downloaded and shared. In the middle, we have the backend service powered by Fast API. This manages authentication, course and lesson management, assessment, and progress tracking. It also includes offline sync manager that ensures data collected offline is safely synchronized when connectivity is available. On the right, we have the AI and NLP service. This includes a low-resource translation API fine-tuned for African languages and adaptive rule engine that helps personalize the learning path for each student. Supporting everything is our data and storage layer, a content store for lessons and media, plus a technical vocabulary database for STEM terms, translation, and local analogies. Finally, at the bottom, we integrate a community Q&A and collaboration platform where students and teachers can ask questions, get help, and interact, moderate by our NLP services to keep the space safe and accessible. Our roadmap is clear. Phase 1, MVP development validation. We begin in the Democratic Republic of Congo, where the need is immense. and the potential is huge. Physics will be our entity point, delivered bilingually in Swahili and English-French. Our first milestone is simple yet powerful. Build a mobile-first, offline-first platform with a lightweight adaptive engine and 2D virtual labs covering 10 to 15 concepts. Within 12 months, we aim to see real classrooms using it, 10 to 15 pilot schools where teachers adopt the system and students experience measurable gains in understanding. This is where the vision meets reality. Once we prove that the impact, we expand the platform growth to a second subject and we introduce another high-value African language like Yoruba. But this phase isn't only about learners, it's about teachers. We launch a teacher dashboard that gives them analytics, content tools, and visibility into student progress. At the same time, we create a community space, a digital hub where students and teachers interact, ask questions, and learn collaboratively. In this phase, the hub evolved from a tool into a community learning. A solution only matters if it lasts. That's why phase 3 is about building sustainability. We rule out a blended revenue model, institutional subscriptions for schools and NGOs, a freemium course so students always have access, and partnership grants aligned with SGD 4. This phase also depends on collaboration with African NLP leaders like Masakan and Lilapa, strengthening the localized STEM data pipeline so that translation, terminology, and concepts become uniquely African. Finally, with strong foundations, we scale the hub. We'll expand it into multiple countries and languages, bordering to cover chemistry, biology, and mathematics. Advanced features like AR, predictive AI models, and adaptive simulations will be added, making learning more immersive and personalized. Behind our project is a strong network of mentors and committed core team, ensuring both technical strength and ethical responsibility. Our Pan-African team brings the project to life. Our mentors include Eli Alex Kamin from Cameroon, a machine learning engineer, David Kram Kadura from the DRC, an EMS Edinburgh scholar in reinforcement learning, and Issa Bamia from Mali, co-founder of AI Mali and expert in African language AI. We also embed responsibility at our core, tackling data bias through human-in-the-loop creation, bridging infrastructure gaps with offline-first design. Sustainability is built into our model. Freemium access keeps learning free for students. Institutional subscription for schools, NGOs, and ministries provide revenue. Partnership grants aligned with HDB 4 reinforces financial sustainability. By starting small, we can build Africa's first scalable digital backbone for STEM education. We can reduce the STEM skills gap, give out of school youth a second chance, empower women in STEM, transform Africa's young population into greatest advantage. Today, we are not just pitching an idea, but a movement. We are seeking partners, mentors, and supporters to bring this vision to life. Together, let's ensure that the next generation of African scientists and engineers is ready to shape the world. Thank you.